All right, pre-calculus, welcome to your quiz review video for 3-4 to 3-6. In the house today, we have food sponsors of Bobo's, PB&J's grape, actual Laura Bar, Target version of the Laura Bar, and another Target version of the Laura Bar. And brought to you by Newt the Trail Kitty. R.I.P. Newt. R.I.P. Okay, here we are on your quiz. Next Tuesday, you will see the following questions. 1 through 3, find the domain of each rational function. Find any horizontal, vertical, or oblique asymptotes. All right, so we can go in any order. Horizontal asymptote might be the easiest to find. First off, we look at the power. Where's the highest power? Highest power is in the denominator. If the highest power is in the denominator, the horizontal asymptote is y equals 0, always. There it is. All right, then we talk about the vertical asymptotes. We don't like, that's x plus 2. This is going to be x plus 3 times x minus 3. Nothing's going to cancel. Because remember, if it does cancel, it's not a vertical asymptote. It's a removable discontinuity, so we're not going to name it. So I should have factored it, but it doesn't cancel. Anyway, we said x squared minus 9 equals 0, or x plus 3, x minus 3 equals 0. We get x is plus or minus 3, so my vertical asymptotes are x plus or minus 3, which means if nothing cancels, my vertical asymptotes lead directly to my domain. My domain is any x such that x doesn't equal plus or minus 3. This is not that hard of a section, okay? This is not going to be the easiest quiz, but it's not impossible. You've had this review and these answers for a long time. All right, take a look. So first off, on this one, the highest power is in the numerator, and it's bigger by 1, which means there is an oblique asymptote. So I'm going to pause. There's no horizontal asymptote. There is an oblique asymptote, though. All right, this doesn't factor. All right, it's not x plus 2, x plus 2. In fact, if you set this equal to 0, you get plus or minus 2i, which means it doesn't have an x-intercept. All right, so because it doesn't factor, to find my vertical asymptote, I simply set x minus 2 equal to 0, and I get x is 2. So you could say the domain is negative infinity to 2, union 2 to infinity, or I'm going to allow for sure, you can say the domain is x such that x doesn't equal 2. You can use set notation all you want. Okay, so we have the VA, we have the domain. It has, and I could have done this as well, folks, because this is nice. So you can either do long division, especially if you're dividing by like x squared. You can also do synthetic division. So 1x squared, 0x, and 4, and I'm going to set x minus 2 when I'm dividing by. I'm going to set equal to 0, so I get x is 2. I put that in the cubby. I can do synthetic division here because of what I'm dividing by is linear. This exponent is 1. All right, so bringing down the power, I get 1. 2 times 1 is 2. Add them up. 2 times 2 is 4. And I get a remainder of 8 again. Again, we're basically treating this as 8 over x plus 2. And as x gets bigger and bigger and bigger, as it goes towards infinity, which is what happens with a vertical asymptote or a horizontal asymptote. I know it doesn't have one here, but the kind of rules applies. As you keep going to the right, this 8 over x plus 2 is going to become 0. So this stands for 1x plus 2. And that is the oblique asymptote. The oblique asymptote is an equation. Y equals x plus 2. I think the oblique asymptotes will be the hardest part. But again, practice early, we can do it. Here's what I recommend on 3. So first off, the highest power is the same. All right. You just factor it as, I mean, because if you multiply this out, you get x squared plus 4x plus 4. X squared over x squared, I mean, you have the same highest power. And then it's the ratio of the leading coefficients. 1 over 1. So the horizontal asymptote is y equals 1, the ratio of those leading coefficients. So you have an example of each. All right, then I would factor. All right, so you have x plus 2, x plus 1 over x plus 2, x plus 2. All right, the x plus 2's cancel. So your vertical asymptote is x equals negative 2. Like this was going to be x equals negative 2 as well, so it doesn't Doesn't really change much. But you have a vertical asymptote as x equals -2. Again, you can write your domain as negative infinity, -2, union -2 to infinity. Or you can say the domain is x such that x doesn't equal -2. All right. Find all x-intercepts, the y-intercepts, and mention any asymptotes. State the domain. 4 through 9. So it's going to be worth an okay amount of points. Okay, because it's what? Asking for 5 things. We spent a lot of time practicing. You have a lot of these on your homework set. Again, these are always good notes for your homework set. Hint, hint, wink, wink. So let's find the x-intercept first. Nothing cancels. You can't cancel off those x's because of that -6 there. So the x-intercept is when I get an answer of 0. Remember, I have a fraction. How do you get an answer of 0 for a fraction? That's only if the numerator is 0. So I set the numerator, 2x minus 6 equal to 0. I get 2x equals 6. I get x is 3. X is 3 is my x-intercepts. Okay, so my y-intercept is when x is 0. Well, when x is 0, I get -6 over 0, which is undefined. One of you asked about this because it happens on your homework sets. So you have no y-intercept, no big deal. All right. Let's do the vertical asymptote because it leads to the domain right away. So the vertical asymptotes, nothing cancels. So I set the denominator equal to 0. That could not be easier. You get x is 0. So you could say the domain is negative infinity to 0, union 0 to infinity, or you can say the domain is x such that x doesn't equal 0. Either works. Lastly, the horizontal asymptote or the oblique. It says state any asymptotes. I have the same highest power, so it's the ratio of the leading coefficients, 2 over 1. The ha is 2, y equals 2. All right, so let's take a look at this one here. Capital H of x equals blank. Does anything factor or cancel? It doesn't. So these are not opposites. Nothing cancels. For the x-intercept, I simply set the numerator equal to 0. I get x as a -2. For the y-intercepts, again, I let x be 0. So if I let x be 0, I get 2 over 0. Or if I distribute it here, I get 2 over 0. So again, 2 over 0 is undefined. 2 straight, no y-intercepts. So if it happens on your quiz, don't freak out. Nothing cancels, so I simply set my factor denominator equal to 0. X equals 0, x equals 2 are my 2 vertical asymptotes. What's my horizontal asymptote? Well, folks, the highest power is, once you find the vertical asymptote, go find your domain because it leads right into it unless something gets canceled. So I have 2 no values for x, 0 and 2. My domain is x such that x doesn't equal 0 or 2. Again, this leads to this. Lastly, horizontal asymptote, y equals 0 because the highest power is in the denominator. Highest power is in the denominator, which means horizontal asymptote is always y equals 0, which means next year the limit as x goes to infinity, gonna be 0. All right, let's take a look at number 6. You're gonna factor number 6. All right, and when I factor number 6, I notice nothing cancels. Very, very close, but nothing actually cancels. Interesting. All right, so my vertical asymptote, I set x plus 3 equal to 0, x minus 2 equal to 0. Vertical asymptote, my x-intercepts. Set my numerator equal to 0, and I get x is -3 and x is 2. For my y-intercepts, go back to the original. If I let x be 0, I get -6 over -6. My y-intercept is y equals 1. All right, my vertical asymptotes, nothing cancels. I set my denominator is equal to 0. I get x is 3, x is a -2, which leads nicely to my domain. Any x such that x doesn't equal -2 or 3. I do have a horizontal asymptotes because the highest powers are the same. So it's the ratio of the leading coefficients, which is 1 over 1, y equals 1. All right. Let's take a look at 7. I might quickly go over these because, gosh, there's a good amount of questions, and they do take a little bit of work. All right, so up here, nothing cancels. Let's take a look first at the x-intercept. I have x to the 3rd equals 0, so x is 0. Set the top equal to 0. I simply get 0. All right, for the y-intercept, I let y be 0, which means I'm going to have 0 over -4, which is not undefined. It's simply 0. The y-intercept is 0. It goes through the origin, 0, 0. All right, what's next? Nothing cancels through factoring, so I'm going to find the vertical asymptote. I'm going to set x squared minus 4 equal to 0. I get x is plus or minus 2, which means the domain is x such that x doesn't equal -2 or +2. All right, my highest power is in the numerator by by 1, which means there's no horizontal asymptote, but there is an oblique asymptote. And what I'm dividing by is not linear, it's x squared. So I need to write this, I need to do long division. X to the third plus 0x squared plus 0x plus 0. I'm dividing by x squared minus 4. I ask myself, x to the third divided by x squared, what is it? It's x. Then I take x and multiply it by x squared, x to the third. I take x and multiply it by -4, -4x. There's no 0x squared there. Okay, so when I subtract, that cancels. There's nothing there anyway. 0 minus a -4 is a +4. This is like the remainder because 4x squared does not go into 4x. All right, you're going to have 4 over x. I mean, if you think of it as 4 over x, and then x is, well, we're not gonna go down there. It's part of the remainder, and it doesn't matter in this situation. So my oblique asymptote is simply y equals x. Y equals x is my oblique asymptote. All right. Hey, just look at the answer here for 8. Notice that the highest power is in the numerator, so there is no horizontal asymptote, but it's bigger by 2, so there's no oblique asymptote either. We don't do anything there. It's not bounded by anything vertically. All right, so the y-intercept, again, it's 0 over -1 squared, which is 0. The x-intercept, I set this equal to 0. I get 0. For the vertical asymptote, I set x minus 1 equal to 0. I get x is 1. My domain, -infinity to 1, union 1 to infinity. Or my domain is x such that it doesn't equal 1. All right, and then number 9. Honestly, number 9 is like number 6. It's very much like number 6. All right, so that's one more I just want you to look at. Again, if I make a boo-boo, tell me in class. All right, we need to talk about the next part. Solve each inequality. All right, so first off, you need to move this over. We're going to factor it. We're going to treat it like it's x to the third plus x squared minus 4x minus 4. 4 terms, I can luckily factor by grouping here. Factor out the x squared they have in common, leaving me with x plus 1. I always bring down the sign in the middle, which is a negative. -4x divided by -4 is x. -4 divided by -4 is a +1. X squared minus 4 on the outside. It gets grouped in one parentheses. X plus 1. Those two parentheses, I see that they're the same. They're duplicates. I write it as x plus 1. All right, and then again, I'm treating it like it's equal to 0. I know it's technically less than, right? Right here. So I do the cover-up method. X squared minus 4 is 0. I get x is plus or minus 2. X plus 1 is 0. I get x is a -1. So I'm going to have 3 critical points, -2, -1, and +2. So my intervals are -infinity to -2, -2 to -1, -1 to 2, and 2 to infinity. I mean, 4 intervals, that's the most I'm going to give you on a quiz. Now I need to find test numbers. What's a good number to use from -infinity, -2, -3? How about in between -2 and -1? You can call it -1.5. That's fine. Between -1 and 0 and 2 has to be 0, definitely. 2 to infinity, let's use 3. Okay, so what we're going to do is we're going to ask ourselves, using these test numbers, is this statement true or false? So I'm going to go back to the best factored form here. I'm going to plug -3 in for x here and here. If I plug -3 in for x, I get a positive times a negative, which is a negative, which is less than 0, true. If I plug -1.5 in for x, I get a negative times a negative, which is a Yeah, so you get a negative times a negative, which is clearly a positive, right? And is it a positive number less than 0? No, false. All right, if I plug 0 in for x, I have negative 4 is less than 0, right? Which is true. Okay, or I have a negative times a positive, which is a negative. And then lastly, if I plug 3 in for x, I get a positive times a positive, which is a positive. Is a positive less than 0? It's not. So my answer is going to be negative infinity, negative 2. You need negative 1 to 2. Both count, or use parentheses for everything because it's a less than. There's no asymptote. So it's, again, if you use parentheses for everything on your quiz, I'm not going to, or homework set, I'm not going to count you wrong this year. All right, so 11 is very, very much similar to this last question. All right, in fact, I want you to look at the work for 11 because they're literally not really different. You're going to factor by grouping. Just be careful. They don't have anything common, so you factor out a negative 1. You got to bring down the negative on the inside. You divide both terms by negative 1. X squared minus 1, x plus 4. Set this equal to 0, set this equal to 0. Those are your intervals. You got your test numbers. All right, negative 5, negative 2, 0, 2. And you're going to plug it into its best factored form. Plug negative 5 in for x, positive times a negative. Is that greater than or equal to 0? False. Plug in negative 2, a positive times a positive. Is that greater than or equal to 0? True. Plug in 0, so then you literally get what? Negative 4 is greater than 0, which is false because you get a negative times a positive. Then plug in 2, you have a positive times positive, which is a positive. Now again, if on your quiz you told me negative 4 to negative 1, union 1 to infinity, I'm not going to count you wrong. But technically, because it says greater than or equal to, you're going to put brackets around the non-infinity. All right, I know some of these are a bit rushed, but like these questions take a lot of work. Okay, so can't make a 30-minute video here. All right, let's take a look at this one. So there's two different methods. I recommend this one. We call this method A in class the other day. First off, you set the denominator equal to 0. You get 1 minus x equals 0. So x equals 1. Think of that as a vertical asymptote there. And if you actually simplify that and move that over, that would be the case. Okay, then just cross multiply. Okay, so 2x minus 6 is less than 2 minus 2x. Add 2x to both sides. Add 6. 4x is less than 8. X is less than 2. So think of it as x equals 2. So you have two critical numbers here, critical points. I'll say them interchangeably. You have 1 and 2. So I have negative infinity to 1, 1 to 2, 2 to infinity. All right. Let's see, 31 divided by 96. Okay, so I'm going to use 0, I'm going to use 1.5, I'm going to use 3. Now, here's where I got to be careful because I'm not comparing it with 0. I'm comparing it with 2. Is this statement less than 2? So I do actually need a value. When I plug 0 in here, I get a negative 6 over 1, which is a negative 6. Is negative 6 less than 2? True. Then I take 1.5 and I plug it in for x. If I plug in 1.5 up here, I get negative 3. If I plug in 1.5 here, I get a negative 0.5, which is positive 6 if you divide, and that's not less than 2. Then if I plug 3 in for x, I get 0 over negative 2, which is 0. Is 0 less than 2? It is. Okay, so I have to compare it to 2, not whether or not it's positive or negative. All right, it's a less than situation, so everything's got to be in parentheses. All right, again, you can use parentheses for everything. That is fine. All right, we're getting close. Let's take a look at 13 and 14 here. So it is terms of 0, and it's been factored. This is lovely. Set this equal to 0, set that equal to 0, set that equal to 0. We get x is 2, 1, and 3. Okay, 3 critical numbers, which means 4 intervals. Negative 1 to infinity, negative infinity to 1, 1 to 2, 2 to 3, 3 to infinity. Find your test numbers. Good number 0, 1.5, 2.5, and 4. Okay, so again, well, what's nice about here is because it's in terms of 0, I just really care, is this going to be positive or negative? Because it's in terms of 0. And to be greater than 0 is positive. To be less than 0 is negative. Now, if it was in terms of 1, I would have to cross multiply, number 1, or 2, have to cross multiply, and then I would have to compare it to either 1 or 2. If I plug 0 in for x, I get a negative times a negative over a negative, which is a negative. It's false. It's not greater than or equal to 0. If I plug in 1.5, I get a negative times a positive over a negative, which is a positive, which is greater than or equal to 0. If I plug in 2.5, I get a positive times a positive over a negative, which is a negative, not greater than or equal to 0. If I plug 4 in for x, I get a positive times positive over a positive, which is greater than or equal to 0. True. All right, because it's greater than or equal to, I should use bracket when I can. 1 is an x-intercept, so it would be 1 to 2, both in brackets, but 3 is a vertical asymptote, so it never gets a bracket. Again, if you said 1 to 2 in parentheses, this year, fine. Okay, here's 14, very much similar to 13, only you're going to have, okay, so this is a bit much, honestly. You have 4 critical numbers, and then you have 5 intervals. So that's a bit mean, but it's the same sort of situation, and it's in comparison with, it's being compared to 0. Look at that one. I'm going to look at 15. Your quiz is good. It's ready to go. It's scored. Has a very generous buffer, and there's really nothing wrong with it. It's fine. It's not harder than this, okay? Sometimes your quiz reviews, usually your quiz reviews are harder, so just know how to do this stuff, folks. So we're going to move this over. We're going to have x to the 4th minus 4x squared is greater than 0. We're going to factor out an x squared from both those terms, leaving us with basically x squared equals 0 and x squared minus 4 equals 0. Again, it's like this. Cover our method, x equals 0. If x squared minus 4 is 0, then I get x squared is 4, x is plus or minus 2. 3 critical numbers, 4 intervals. Negative infinity, negative 2, negative 2 to 0, 0 to 2, 2 to infinity. Test numbers of negative 3, negative 1, 1, 3. All right, this is my best factored form. So I'm going to use this. I'm going to ask myself, is this statement x squared times x squared minus 4 greater than 0? So I plug negative 1 in for x. So this is always going to be positive because you're going to square something. So I can just put positives all the way down. If I plug negative 3 in for x, I get a positive here. Positive times positive is greater than 0. True. If I plug in a negative here, I'm going to get a positive times a negative, which is a negative. False. If I plug in 1 here, I'm going to have positive times a negative, which is a negative. False. If I plug in a positive here, I'm going to have a positive times positive, which is positive. So it's true. All right. Negative infinity, negative 2, union 2 to infinity would be my answer. No bracket. It's greater than. All right. Anyway, there it is, folks. This is Yak Math Videos signing out.